Here's an example of how catch rates can reflect abundance. We've put 200 goldfish in a tank, and here's our trawl net. What we're going to do is look at how catch rates change as the population decreases. So, our fisherman takes his first shot. Counting them out, he got 19 fish in the first shot. Speeding things up a bit, he's now taken 4 shots and caught 50 fish. He's now reduced the population to 150 fish, which is 75% of the original population. Catch rates have been pretty high so far. Let's get the fisherman to keep fishing and see if catch rates change. Now, the population is down to 60% of its original level, and you can see it's getting harder to catch fish. Catch rates have dropped right off. This example demonstrates that catch rates can provide some index of abundance. This is pretty simple, right? Not in real life. As you'd expect, catch rates don't only change with fish population size, but, among other things, with fishermen, gear types, seasons and depths fished. All of these things need to be accounted for. This is called catch rate standardisation. And to show you how this works, we'll compare our first fisherman with a new entrant. Our first fisherman has been in the industry a long time and had pretty good catch rates. His gear is set up right and he knows just the right speed to tow. Let's see how the crazy scientist does. It looks like his gear isn't as good and his tow speed is much slower. Eventually he does catch the same amount of fish as the fisherman, but it takes him twice as long. So the crazy scientist ends up with less than half the catch rate. Now, it's obvious that comparing catch rates between fishermen won't tell us anything useful about population size or changes in population size. So what we need to do is compare catch rates of the same fishermen over different years. So, let's get them both back onto the fishing ground. Because the population had decreased, both fishermen have lower catch rates. If we do the maths on this, what we discover is that although their catch rates are very different, they have both experienced the same fall in relative catch rates. In each case, they both experienced about a 50% drop in catch rate. The next step is to standardise the results, which means to even out the differences between high catch rates of one fisherman and low catch rates of another. Going back to our fish tank results, in the first year our fisherman had a catch rate of 7 fish per shot and the crazy scientist had a catch rate of 4 fish per shot. In the second year abundance has fallen, so our fisherman only had a catch rate of 3.5 fish per shot and the crazy scientist only 2 fish per shot. We know that the major reason for the catch rate difference was that the crazy scientist had a smaller net, and scientists need to even out the differences caused by the different nets to make the results comparable. Remember, we're not interested in the comparison between fishermen, but the comparison between years, so we can understand changes in abundance. The process of standardisation then means that in our fish tank example, we want to make the first year's catch rates the same. In this case, we'll use round numbers and make the first year's catch rate 1. To achieve this, we divide the first fisherman's catch rate by 7 and the crazy scientist's catch rate by 4. Now going to the second year, we do the same thing. Divide our fisherman's catch rate by 7 and the crazy scientist by 4. What we've done here is standardised both their catch rates and therefore adjusted for the fact the crazy scientist had a smaller net. Result? Even though the catch rates were very different, by standardising them we can clearly see that the changes in catch rates were the same. The catch rates could now be combined to get an average catch rate for the fishery for each year. Applying this process to a commercial fishery is exactly the same, but over a much larger number of fishermen and more variables. Those variables being things like gear type, depth, season and area. Looking at standardised catch rates over a number of years, scientists can tell if a fish stock is going up or down. The large number of logbook records provided each year across a whole fishery helps to show the bigger picture that might be hard to see in the catch rates of any one fisherman.